Yes, students. Jai Swaminarayan. Welcome to our first video lecture of chapter 5. As I told you, students, chapter 4 and chapter 5, students, both these chapters are going to be very interesting. Now, chapter 5 is differentiation, and weightage of this chapter is, students, 12 to 14 marks. Sometimes they ask questions worth 14 marks from this particular topic. Now, differentiation, students, this topic will be, you can say, very important for you in all your college and graduation and even post graduation. Base of this is mathematics. It has nothing to do, students, with statistics. Base of this is mathematics, students. It has nothing to do with statistics. So first topic of the chapter is, students, definition of derivative and differentiation. Define derivative. Students, pay attention. Definition is bit long. Let f be a function defined from a to r. So, domain of this function is a, and a is any open interval. Now all of you are well versed with interval, and definitely subset of R. So the first point in the definition is, students, f be a function defined from a to r, where a is the domain, r is the codomain. Second point, a is specifically an open interval which is subset of R. This is clearly mentioned in the text. A is an open interval of R, means a subset of R. Now, students, small a belongs to capital A. It means that A is any value which is an element of domain. And if limit h tends to 0, f of a plus h minus f of a upon h exists, then limiting value is called derivative of f. Derivative of f at a denoted by, students, which is denoted by f dash of a. So this answer is nothing but derivative of f at a is denoted by the symbol f dash. So definition is bit odd, but if you understand, it is very simple. The first point, f is any function, students, defined from a to r. A is domain, r is codomain. That much all of you know functions in 11th standard. We have definitely studied. So f is a function defined from a to r. A is any open interval, definitely subset of R. Of R means subset of R. Small a belongs to capital A means small a must be an element of domain. If small a doesn't lie within domain, we cannot find derivative. So this is an important condition. And if, students, I double f if I have it means that if limit does not exist, if this limit does not exist, then derivative is not possible. So if this limit exists, then limiting value. What do you mean by limiting value, students? Limiting value is called answer of limit. Is called derivative of f at a value a, which is denoted by f dash of a. So if it is derivative at b, students, we denote it by f dash of b. If it is derivative at c, students, we denote it by f dash of c. So this limit h is very small value, students, and even a plus h should belong to domain, because h tends to 0 means h is a very small value. If I add h to a, then a plus h will be also an element of domain a, and if this limit exists, students, answer of limit means the limiting value is called derivative of f at a value a, which is denoted by, students, f dash of a. So I am summing up the definition. Last time we had mentioned that f be a function defined from a to r, and a is any open interval subset of r. Small a belongs to capital A means small a is an element of domain, and if this limit exists, answer of limit or limiting value is called derivative of f at a value a, students, which is denoted as f dash of a. So students, if this limit does not exist, derivative does not exist. So derivative is nothing but a special type of limit. The process of finding derivative, students, is called differentiation. The process of finding derivative. The process of finding derivative is called the title of the chapter, which is nothing but differentiation. What do you mean by process of finding derivative? Process of finding derivative means whatever step we do to find limit, those steps are involved to find limit is indirectly called the differentiation. So process of finding derivative, students, is called differentiation. So process of finding derivative of a function, students, is called differentiation. So this, students, you have to very carefully, students, understand. I hope this is now very clear. Once again, both these definitions. For exercise 5.1, we have only two definitions and two formulas. So I am revising and reiterating the definition, students, once again. Let f be a function defined from a to r. A is domain, a is any open interval subset of r. Small a belongs to capital A, and if limit h tends to 0, f of a plus h minus f of a upon h exists, then the limiting value, the answer of limit, is called derivative of f at a value a, which is denoted by f dash of a. And students, the process of finding derivative, students, the process of finding derivative is called differentiation. So this definition, student, you have to memorize. Now, if I replace this a by x, then I get derivative at x. If I replace this a by y, then I get derivative at y. If I replace this a by b, I get derivative at b, students. So please try to recall, try to understand the definitions as and when required. Part 2, students, is very less theoretical, very interesting compared to part 1, because we don't have, students, long tables which are to be made. So there is no problem, students, of, you can say, making mistakes in total. Now, students, we are going to, you can say, start exercise exercise 5.1. The formula which you have to repeatedly memorize for exercise 5.1 is only one formula, and that is, students, f dash x is equal to limit h tends to 0. Instead of a, I am writing x, f of x plus h minus f of x upon h. This is the formula which is used to find derivative using definition. So today's lecture, students, we are devoting to exercise 5.1. Now, the first question, fx is equal to 2x plus 3, students. The first question, exercise 5.1, main question 1. Given function is fx is equal to twice x plus 3. Okay, students, this is our given function. Now, I am leaving some space and writing according to definition. F dash x is equal to limit h tends to 0 f of x plus h minus f of x upon h. Now, students, pay attention. In the definition, we have f of x plus h. So, after writing function, immediately we write f of x plus h. Replace this x by x plus h. So, if I expand, this becomes 2x plus 2h plus. So, in this type of sum, it is told to find derivative using definition, students. Obtain the derivative of following functions with the help of definition. So, whenever it is a sum of derivatives, students, using definition, we have to go by this standardized approach. So, this becomes limit h tends to 0. Now, what is f of x plus h? It is this. Don't wonder how we have written 2x plus 2h plus 3. What is f of x? 2x plus 3 and divided by h as it is. Okay. Now, open up the brackets. So, limit h tends to 0. 2x plus 2h plus 3 minus 2x minus 3 upon h. 2x cancel, 3 minus 3 cancel. What remains? 2h upon h. So, limit h tends to 0, 2h upon h. Again, this h and h also gets cancelled. Limit of 2 is 2. So, our answer of f dash x is 2. The derivative of this function 2x plus 3 is what? 2. So, students, in the initial approach of derivative, it is nothing but application of limit only. Now, students, I am doing question number 2. Which is again very interesting. Okay, so now I will be at an advantage to write less number of steps. You may have to write sometimes more number of steps. I am at an advantage because I have to only write the layout once. And here I am changing to question number 2. Our sum is fx is equal to x square. Okay, so to write f of x plus h, replace x plus h. So functional values f x plus h will be f of x plus h the whole square. Now, according to definition, this becomes limit h tends to 0, x plus h the whole square minus x square, which is f of x upon h. Okay, students, now this formula of limit x tends to a, x raised to n minus a raised to n upon x minus a is nothing but n a raised to n minus 1. Students, derivative and limit are closely interconnected. What I am saying, students, derivative and limit are closely interconnected. Now all of you know how to do this. There is only one term in the first term, x plus h. It should be only x term, only t term. So we are doing the method of supposition. Suppose t is equal to x plus h. We have already done this in limit. As h tends to 0, t tends to x. As h tends to 0, then t tends to x. Whenever we suppose limit changes, because variable changes from x to t, students. What you have to understand? The variable changes from x to t. So wherever there is h, I can write t minus x. I can take this x to the left. So now check what are the drastic changes. Limit t tends to x, x plus h is replaced by t. So t square, x square as it is, and instead of x I am writing, instead of h I am writing t minus x. Now check this bracket and this bracket, students. Understand the chronology. There it is x tends to a, here it is t tends to x. So our a in this is x and n is 2. And just show you, this is n and this is a. So the answer is what? N a raised to, sorry, so instead of a we have x raised to n minus 1. So the answer is 2 into x or twice x. So this is a, you can say, fantastic application of, students, the formula of limit. Now, if it is x square, the answer is 2 into x raised to 2 minus 1. Suppose this was x raised to 5. The answer will be 5 into x raised to 5 minus 1, which is 4. So, our third sum is nothing but x raised to 7. Okay. So check what I am doing. I am very smart because I am your teacher, isn't it? So I can cut short. Our function is x raised to 7. So this is x plus h raised to 7. Where I have to write 7, you should tell me, students, but you are not virtually present. So this 2 will be replaced by 7. This 2 will be replaced by 7. So this 2 will be replaced by 7. This 2 will be replaced by 7. So my answer is 7 x raised to 7 minus 1. So the answer is 7 x raised to 6. Check. So if it is x square, the answer is 2 into x raised to 2 minus 1. So if the function is, students, x raised to 7, then the answer is 7 into x raised to 6 minus 7 minus 1, sorry, which is 6. Suppose this was x raised to 50, answer would be 50 x raised to 40. 49. Suppose this is x raised to 18. Answer is 18 x raised to 70. Suppose this was x raised to 500. Answer is 500 x raised to 499. So this is again, students, very interesting, and your interest must be there, students, in order to do the sums. I hope this is very clear. Now, students, I am doing the fifth sum. Because I am smart, I don't want to write much. So I am doing the fifth sum. Students, check how much change I have to do. Just remove these powers. Now, students, I am doing the fifth sum. Our function is cube root of x. It is written as fx is equal to cube root of x. Now, cube root of x is written as x to the power 1 by 3. Yes or no? Of course. Students, nth root of x is written as x to the power 1 by n. So, square root is power 1 by 2, cube root is power 1 by 3, fifth root is power 1 by 5, seventh root is power 1 by 7, students. So, now, what are the only changes? This power will become 1 by 3, this power is 1 by 3. So, finally, x plus n is replaced by t, so t raised to 1 by 3 minus x raised to 1 by 3 upon t minus x. Check. So, this is our a and this is our n. So, the answer is n into a raised to n minus 1. So, this answer is 1 by 3, x raised to 1 minus 3 is minus 2 by 3. This is our answer. So, this type of sums, students, are done by a fundamental approach. And once you understand this, students, I don't think that you should ever face any problem in understanding this type of sum. But along with the formula of derivative, students, we have also used the formula of limit. Okay, students, so now I am doing question 4 and 6. Now, erasing, I have to write a little bit. So this much I am erasing, this also I am erasing. This also I am erasing, and I am writing the function. What is the function? 1 upon x plus 1. Okay, the given function fx is 1 upon x plus 1. Okay, of course x not equal to minus 1. So what will be, students, f of x plus h? Replace this x by x plus h. So it will be 1 upon x plus h plus 1. I hope all of you understood this. Simply this x is replaced by x plus h. Okay, this denominator h remains as it is. Now I am substituting the value. What is f of x plus h? It is 1 upon x plus h plus 1. So 1 upon x plus h plus 1. F of x is the given function, which is 1 upon x plus 1 divided by h. This is going to be the simplification. Now your 10th standard taking LCM, cross multiplying. So we will get limit h tends to 0, cross multiply 1 into x x plus 1 is x plus 1, minus 1 into x plus 1 plus h is x plus 1 plus h. LCM is always taken in the denominator. So simplification work, this step you should be extraordinarily sound. Yes or no? Now open up the brackets. So we get limit h tends to 0, x plus 1 minus x minus h minus 1 upon h into x plus 1 into x plus h plus 1. X and minus x cancel, 1 and minus 1 cancel, and in next step h and h also gets cancelled. So limit h tends to 0 minus h upon h into x plus 1 into x plus h plus 1. Cancel this as h and h. Now I am taking limit. Replace all h by 0. Minus 1 as it is. X plus 1 as it is. Only replace h by 0. So this becomes x plus 0 plus 1. So x plus 1. So the answer is minus 1 upon x plus 1 the whole square. So derivative of the function fx is equal to 1 upon x plus 1 is students minus 1 upon x plus 1 the whole square. So still we have to develop the formula, students, but this is nothing but the derivative of the function. Fx is equal to 1 upon x plus 1. Okay, now students we are doing sum number 6. Now students we are doing sum number 6. It is fx is equal to 2 upon 3x minus 4. Fx is equal to 2 upon 3x minus 4. So f of x plus h will be 2 upon this x will be replaced by x plus h minus 4. Thus here you observe again very carefully to write the functional value at x plus h. Students, to write the functional value at x plus h, replace every x by x plus h. Now this becomes 2 upon, if I multiply 3, what I will get? 3x plus 3h minus 4. Fx is 2 upon 3x minus 4 whole divided by h. This is our repeating value. Cross multiply 2 into this. Again minus 2 into this. Upon h into 3x minus 4 into 3x plus 3h minus 4. This step is decisive. Open up the brackets. So limit h tends to 0. 3x into 2, 6x minus 8 minus 6x minus 6h plus 8 upon h into 3x minus 4 into 3x plus 3h minus 4. 6x, 6x, 8 minus 8 gets cancelled. So what remains? Limit h tends to 0 minus 6h upon h into 3x minus 4 into 3x plus 3h minus 4h and h gets cancelled. So now it is a simple simple step, replace every h by 0, remaining as it is, minus 6, this 3x minus 4, we don't touch. This will become 0, so again it will be 3x minus 4. So the answer is minus 6 upon 3x minus 4, the whole square. So this is the one answer, students. So almost all similar steps, the main part is to go for simplification. The main part is, students, your 10th standard. And if you are well versed or if you have simplified perfectly in 10th standard, this type of questions will not be difficult for you students. Now the last sum of the lecture and the exercise we are doing. Students, the last sum of the lecture and exercise we are doing. It is sum number 7, fx is equal to 10. So what will be f of x plus h? 10. Because is there any x to be replaced by x plus h? No. So when it is a constant, f of x plus h will be also the same. Understood, students? There is no x on the right hand side which is to be replaced. So this becomes limit f of x plus h 10, f of x 10 upon h. So this becomes limit of 0 upon h, 0 upon h is 0, limit of 0 is 0. So the answer is 0. It means derivative of 10 is 0. Even if I would have written here 100, then this would be 100 minus 100, still 0. If I would have written root 11, then this is root 11 minus root 11, still 0. It means, students, derivative of a number is 0. If I write 10 or 100 or 20 or minus 2 or root 2 or root 5 or 7 by 9 or 11,000 or 10 crore, derivative of all these values will be 0. So we have come to some new conclusion that derivative of a number or a constant is 0. Derivative of a number, derivative of a constant is 0. Remember this as a result. Derivative. Number means a constant. Derivative of a constant is 0. This we have to remember.